So this lesson is on rationalizing the denominator or dividing complex numbers and using the quadratic formula to find the solution or complex solutions. All right, so the first thing I just want to bring to your attention is that remember we said that I squared gave you a value of -1, okay? So if we were to simplify these terms, if I just, put I to a power, and I just kept doing that, and I kept going on and on and on, okay, just changing the power, 1, 2, 3, 4, 5, 6. The first term would be a value of I, and then remember I squared is -1, okay? Now I want you to look at I cubed. That's I times I squared. Well, I squared is -1, which will change that to a negative I. All right? Then I to the fourth is I squared times I squared. If this is -1 and this is -1, -1 times -1 is a +1. Okay? I to the fifth is I to the fourth, which we said was 1, times I. So that would just be I. All right? I to the sixth would be I to the 4 times I to the square. Now we said I to the 4 was 1, and we know that I squared is -1. So 1 times -1 is -1. Now do you notice a pattern that is going on? I've got I, -1, I, +1. I, -1. This is going to be -I, +1. I, -1, I, +1. And that pattern is going to keep on going on, okay? So just realize that you can simplify powers on your I expressions there, okay? All right. Now, let's talk about rationalizing the denominator. Do you remember when we were talking about a radical or rational radical expressions, and we were dividing? And when we had a radical in the denominator, we said we could not leave it there. So we would multiply by that denominator in the top and the bottom so that we could multiply by 1, but remove that number out of the radical so that now we had no radical in the denominator. We would multiply this out to square root 2 plus square root of 6. And that would be our answer simplified because we cannot leave a radical in the denominator. Well, the same thing occurs with a complex number. We cannot leave a complex number in the denominator. Therefore, we must rationalize it. And just like this square root of 2 that was in the bottom, we're going to multiply by our imaginary number. Now I'm multiplying by the same thing that's down here, so that now in the denominator I have 9I squared, and the I squared cancels, and this is becoming a -9. On top, I'm going to have to multiply. So that's 6I plus 3I squared. And again, that I squared goes away, and that's a negative. Now let's see what we have. We have -3 plus 6I over -9. Now all of these numerical values will be divisible by 3. So I'm just going to divide everything by 3. And that is going to give me my answer. Okay? You could also write it as a +1 minus 2I over +3. So either one of those works. And the reason we can get this second one is we just divided by negative on the top to get rid of it in the denominator. Okay, so I want to try a couple of these. Okay? All right, so we're going to multiply by the denominator. On the top, we're going to distribute 10I plus 6I squared. And on the bottom, we're going to multiply 4I squared. The I squares go away and change the sign of the term in front of it. So in the proper order, we have negative 6 plus 10I divided by negative 4. Now, all of these are divisible by 2, and I'm going to get rid of that negative as well. So I'm going to divide everything by negative 2. So it gives us 3 minus 5I over 2. Okay? We should not have a complex number in the denominator. So if there's one in the denominator, you are going to have to multiply it out. Now, this is a single term, so we can multiply by 1 using that single term, 4I. The top will FOIL, or distribute. And the bottom will multiply. The I square goes away and changes the signs. In a proper order, we put the real number, the imaginary number, over the denominator. We can divide everything by negative 4. Negative 4 goes into all of these numbers. So if I divide everything by negative 4, this is what I get. Okay? Now, that is a single term in the denominator. Okay? Now, let's talk about if we have an expression in the denominator. Just want to remind you what we did when we had radicals down here. Okay? But this is an expression. It's not just a single term. So in order to rationalize this denominator, I have to multiply by an expression that will eliminate the radical. And all I'm going to do is use the same expression, only I'm going to change the sign. Notice it says 1 minus square root of 2 in my problem, and I'm multiplying by 1 plus square root of 2. Okay? So let's do the foiling. 2 times 1 is 2. 2 times square root of 2 is 2 square root of 2. And 3 square root of 3 times 1 is square root of 3. Square root of 3 times square root of 2 is square root of 6. In the denominator, what happens is we have 1 plus square root of 2 and minus square root of 2. So the plus square root of 2 and the minus square root of 2 are going to cancel each other out. And then we have this square root of 2 times square root of 2, which is square root of 4 or 2. That comes out because it's 2 of a kind. The top we simplify as much as we can, and we can't simplify it any more than it already is because we've got 3 different radicals up there in this particular problem. The denominator, we do this 1 minus 2. So that's a negative 1. All that's going to happen is all the signs are going to change. And we don't have to have the negative 1 anymore. Okay? So sometimes it'll eliminate the denominator altogether. So let's try it with our imaginary numbers. Again, because we have an expression in the denominator, we have to multiply by an expression, but we're going to change the sign. Okay? Because the goal is to eliminate the middle. The middle is what will have your I. Okay, remember we did multiplying yesterday. So our middle term has the I. So in the denominator or in the numerator, we're going to just distribute. Okay, so we get 6 plus 2I. In the denominator, we get 9, 3I minus 3I. So that's going to go away. And then we get negative I times I, or negative I squared, or minus I squared. Okay, I squared goes away and it's a 1, a negative 1. So we change the sign, and there's a 1 in front. So we get 6 plus 2i over 10. Everything reduces by 2, so we're going to reduce everything as much as we can. Okay? All right. I want to do another one. I'm going to give myself some more space. Okay? So let's do this one. Actually, let's do this one. All right. So our expression in the denominator is 2 plus I. We're going to multiply by 2 minus I. Okay? Foil the top. You get 4 minus 2I minus 2I plus I squared. The denominator, we get 4 minus 2I plus 2I, which cancel out, and negative I squared. Remember, I squared is a negative 1. So I squared is a negative 1. We're going to simplify. 4 minus 1 is 3, and negative 2i is negative 4i. In the denominator, we have a 4 plus 1, which is 5. Okay? So, multiply by the conjugate, that's what it's called. That's the denominator with an opposite sign. All right? Then complex solutions, we did this when we were working with quadratics. You can use the Pythagorean theorem to, not the Pythagorean theorem, the quadratic formula to solve for these polynomials. Now, we also did this. We took factors and or values, and we rewrote them as factors. So they were equal to x as a solution, but we moved the term back over and made it a factor equal to 0. This gives us our polynomial, and we're able to FOIL it and find our polynomial that we get. Okay? Now, we're going to do the same thing with complex numbers. The issue with complex numbers is if you have one of them, you also have the other. So there's a plus and a minus there. Okay? So I think we did some of these when we were working with polynomials. That's a positive 4. And what we did was we set each of these equal to x, because that's what we solved for. And we just moved each of those factors back to the other side, set the factor equal to 0. And we got our factors. This one's x plus 3. This one's x minus 4. But when we got to the imaginary ones, remember, we moved over the constant value, so we're going to subtract the 2. That left us with plus minus I. Remember, I was a square root of a negative. So this really said plus minus square root of negative 1. That's what it would have said. So we are going to square both sides to get rid of the square root, and then we're going to add the 1. This is the other factor. Okay? Now, I'm not going to spend much time on this because I do want you to get an understanding of the rationalizing the denominator. But there will be a couple of these on the paper. So what you're going to do is you're going to take that imaginary solution, put it equal to x, move over the constant. This is a plus minus whether it says it or not. Rewrite what you think this term was. I is a negative 1. Square both sides to get rid of that square root. And then move your constant value over. And that way you have your factor. So what I'm probably going to do is give you factors that are complex numbers and ask you to find to solve it for 0. Okay? So good luck.